friends, welcome to lecture 62. Where we are going to talk about fire load estimate. Before that, we will complete the numerical problem of blast load estimate on a rectangular building. Okay? We will continue with that. So, we worked out previously the sidewall load. Now, let us work out the roof load for the problem. Okay? For design of a roof, let us consider a strip of 0.3 meter wide and 2.4 meter long. So, let us take L1 as 2.4 meter and let the drag coefficient be 0.4 negative, okay, for the roof. Okay. Equivalent load coefficient will be now equal to LW by L1, which is 20 by 2.4, which is 8.333. So, from the UFC chart, one can calculate CE as 0.9. So, therefore, the equivalent overpressure is given by PA is CE of PSO plus CD of QO, which is 0.9 of 40 plus minus 0.4 of 5.12, that is what we had as Q0, which comes to be 33.952 kilopascal. The rise time for this TR will be L1 by U, which is 2.4 by 398.172, which comes to 0.006 seconds. Okay. So, let us plot this. For the time of duration TD is 0.5, sorry, 0.05. So, the total positive phase duration will be equal to TR plus TD, which is 0.006 plus 0.05, 0.056 seconds. Let us plot this. So, this is 0.006 seconds, this is the positive rise phase, this is 0.056 seconds. Okay. Let us look at the rear wall loading. Let us consider the drag coefficient CD as minus 0.4. So, the equivalent load coefficient will be actually given by LW by S, which is 20 by 5, which is 4 meters, and from the UFSC chart one can find CE as 0.88. So, the equivalent overload pressure is given by PB is CEPSO plus CDQO, which will be 0.88 into 40 plus minus 0.4 of 5.12, which will be 33.152 kilopascal. Time of arrival is TA, which is BL by U, which is 20 by 398.172, which is 0.0502 seconds. Now, the rise time of the positive phase TR is given by S by U, which is 5 by 398.172, which is 0.0125 seconds. Duration TD is 0.05 seconds. Therefore, the total positive phase duration will be equal to T0, which is TR plus TD, which is 0.0125 plus 0.05, which is 0.0625 seconds, which can be plotted as T and PA (0.0125), this is 0.0625, and this value is 33.125 kilopascal. So, friends, this example illustrated how to compute the blast loads on different segments of a rectangular building taken for the study using UFSC code. Okay? Now, let us discuss about estimate of fire loads on buildings. So, friends, we will talk about fire loads. These are some interesting references which you would like to see back when you use fire load computation on structures. Design aids of offshore structures, including fire resistance. This book covers concepts of fire resistant design as well as the special loads. Please have a look at these textbooks which are recommended for this course. In addition, if you want to know about the properties of functionally graded material compared to steel, this is a very nice reference book which is recommended for this course. Okay? Now, let us say steel is the most favorite material for construction. The design procedure for steel structures is well laid. Well established. Okay. For conventional loads, such as live load, dead load, wind load, wave load, current and earthquake loads, we have recommendations given by the codes. Okay. But when you talk about fire load, blast load, impact load, etc. They need a special attention and the analysis methods are different for this. Okay. For example, there are varieties of Indian codes which discuss about the design procedures. For example, let us say IS 456, this is for concrete structures, IS 800 for steel structures, IS 1893 for earthquake loads. Okay. But there are no explicit design procedures available and recommended by the codes for fire loads, right. So, let us see what are the basics of fire load. So, we would like to learn what is a fire load, how fire can occur in buildings, what are consequences of fire load, and how material behaves under fire. Because there are no special design and repair procedures of structures under post fire accidents. Okay? And the steel what we generally use for construction is an high carbon steel. So, there are issues related to these two concerns. So, we need to address them. Okay? But one thing we need to realize is that fire loads if occurs causes catastrophic damage. Okay. Very importantly, no post fire repair is possible. Only rebuilding is done, no repair. It is amounting to a complete renovation, because fire causes a total devastation. Okay. Very importantly, no retrofitting is possible for structures subjected to severe fire loads. Okay. Having said this, let us ask a question: which structures are exposed to fire loads? Do we have to design every building for a fire load? The answer is no. Heavy industrial structures, process industries, nuclear reactor power plants, offshore structures, chemical process plants, can cause fire. We can also include electric substations, because electric fire is an important aspect for design. Okay. Now, let us talk about what do we understand by fire resistant design. Structures can be only designed to withstand fire for a specific duration. Okay. Okay. This is called fire rating. So, please understand friends, there is no fire proof building. There is no fire resistant building, but there are fire safety buildings for a specific duration only. Okay? Then in that case, what is important in fire resistant design? Structural design of members for fire load is only secondary. The primary is public safety. Okay? The primary is public safety. Structural design of members for fire is necessary, but that is only a secondary case. Now, let us see what are the factors that govern the geometric design of fire resistant buildings. Okay. The first one is the firefighting system to access the building. That is, the building should have enough circulation space around the building. The building should have something called a common assembly point, which is also otherwise called as meeting point, which should be known to all the occupants of the building. The building should have a very good evacuation facilities. It should follow public safety under fire accidents. It should have well lit escape routes. It should follow fire evacuation procedure as instructed by the codes. Moreover, and most importantly, all critical items such as fire hydrants, control rooms, fire water tank should be in proper working condition. It should be frequently inspected and certified for its proper working. Okay. Let us quickly see some basics of fire. Friends, fire is a rapid exothermal oxidation of ignition fuel. The fuel can be in the form of solid, liquid or gas. Okay. Fire releases energy, which is an exothermal reaction. Now, within short time, the released energy reaches its peak amplitude or peak intensity. That is a most serious concern as far as fire is concerned. Okay. Now, interestingly friends, fire can also result from explosion. Now, explosion is rapid expansion of gases caused by pressure waves or shock waves. In the previous set of lectures, we understood how to calculate the shock wave and overpressure waves. A rapid expansion of gases caused by these waves can result in explosion. Now, the interesting part is these waves propagate very fast. In the numerical example, you see that they were only in milliseconds. Okay. What is the concern of this? It can cause adiabatic expansion. Explosion resulting from fire can be a mechanical process or a chemical process. Having said this, let us see what are categories of fire. As per DNV code, so DNV code classifies fire as follows: no fire risk. So, the building in that case has no energy resources to catch fire. The example could be home or house. The next is low fire risk. This will occur in buildings which stores non-flammable materials. Which can be examples of academic blocks, schools, colleges, apartments, which stores non-flammable materials. Next could be medium fire risk, which is classified as buildings that has or that have electric and major testing equipments. For example, it can be workshop, lastly, high fire risk. These can be buildings that stores flammable liquid. Example could be process industries, offshore platforms, as well as it also classifies and high power mechanical equipments. So, in that case I can also include electric substation. Okay. Having said this, let us ask a question: how can we avoid fire accidents? Fire used, or let us say the fluid used in such industries which are prone to fire should be above the flash point. It should be above the fire point temperature. It should not be above the auto ignition temperature. Okay. Next, fluid can be used up to the maximum bulk temperature. So, the maximum bulk temperature of any fluid is always much higher than the flash point temperature. Okay? It is a common characteristic of a fluid. Thirdly, no confined space near the ignition source. It should be open from all sides. Okay? No confined space. Further, one should ensure good oxygen supply, or the space should be well ventilated. Okay? But importantly, no oxygen supply near the heat source, near the electric heater, near the heat exchanger, near the drilling controller. Okay? Further, fluid should be contained within the system. There should be no direct contact with the external ignition sources. So, let us see some of the important points for fire resistant design. One, avoid congested layout of workflow. 2. Design the building with good ventilation. 3. There should be no congestion of pipelines. Electric cables or water mains in any flow. Now, let us see what are important characteristics of pipe. One is what we call at auto ignition temperature, AIT. It is also called as kindling point of materials. It is the lowest temperature above which the material may not require any external source for combustion. So, ignition takes place at normal atmospheric conditions when AIT of a fluid is reached. Okay. AIT is called also called as self ignition temperature. It is also the minimum temperature required to supply activation energy required for combustion. Let us say, for example, diesel has got 200 degrees Celsius, methane is 580 degrees Celsius, gasoline is in the range of 247 to 280, butane is about 405. Let us also look at something called a flash point. This is the lowest temperature at which the liquid gives enough vapor to maintain a continuous flame. it is not the temperature at which vapors are produced. Okay. For EC ignition. Okay, it is the temperature, sorry, it is the temperature at which vapors are produced for EC ignition. That is very important. Okay, it is the temperature. So, friends, an important point here is at flash point, fluid will not burn. Okay, that is important. The next one is called as a fire point. It is the temperature at which the fluid will sustain fire if ignited by an external source. But interestingly, fire point of a fluid is always much lesser than the auto ignition temperature. Okay. Since we are writing about the fire resistant design, let us talk quickly about fire protection systems as well for our understanding. There are many fire protection systems available. One is called as the flame arrestor. Flame arrestor, it is a passive device which prevents propagation of fire through pipelines. The second one is called fire barriers, fire insulators, water shower, foams, water spray lines, etc. The third set of fire protection system involves spark preventers. It helps to prevent spark This is one of the highest priority in firefighting systems, sorry, fire protection systems. Of course, the last one, as we all know, is fire extinguishers, which are firefighting systems. Let us have a brief look at the components of firefighting system. Firefighting system should be simple in design. It should be easy to operate. It should be free from high-tech components. it should be maintained periodically. Most importantly, should be available on demand. Friends, the recent research is now focusing on reliability and maintainability. So, looking for reliability and maintainability to check whether any specific system is reliable and available on demand. So, to ensure this, people conduct fire drills at periodic intervals in all industrial structural systems to ensure that the firefighting system essentially works maintained in a proper manner. Okay. Now, friends, as we understand, steel is seen as a very advantageous material. The curve on the screen shows the temperature with reduction factor, which is the strength gradation of steel. So, steel is the most preferred material, but steel has got properties which are dependent on temperature. Look at the effective yield strength and proportional limit as well as the slope of linear elastic range. So, the yield strength, the stiffness and modulus of elasticity all decrease with increase in temperature. Am I right? Especially the yield strength after 400 degrees Celsius decreases significantly. Right? The proportionality limit also decreases beyond 100 degrees Celsius. So, the ductility characteristics, strength degradation happens in steel as you proceed with the temperature. Furthermore, if you look at thermal conductivity of steel, it also decreases with increase in temperature beyond 800 degrees Celsius. It remains constant. Furthermore, the specific heat capacity of steel remains almost constant except at about 7 degrees Celsius it reaches a specific peak where the specific heat capacity touches about 5000 joules per kg Kelvin, close to a range of about 750 degrees Celsius in a temperature. So, these properties of steel which were discussed in the earlier lectures are only helping you to rebrush the constant characteristics of steel with respect to time and temperature. Furthermore, if you look at the thermal strain, it keeps on increasing with increase in temperature. So, therefore, friends, thermal conductivity, specific heat, elastic constants, specific weight thermal expansion and plastic properties of steel all become function of temperature. Okay? So, when you are using steel for a fire resistant design where the fire is going to happen at a higher temperature because of explosion or hydrocarbon fire, etc., you have got to be very careful in understanding the properties of steel which is being used for fire resistant design. Okay? So, friends, in this lecture we learnt about characteristics of fire. We learned briefly about tips for fire resistant design. We also completed a problem on blast loads analysis, and we learned that steel has got properties which are function of temperature, and one has got to be very careful in using these properties appropriately in the design if you are enabling fire resistant design of steel structures. Thank you very much and have a good day.